Let's talk about resistors in parallel now. When we have resistors in parallel, they're not going to add the resistance up. You can kind of see that immediately because we've basically given the resistors the more current more places to go to get from top to the bottom rather than fewer. So it should make it go faster. Okay? In fact, it's like we just increased the total area of the resistors by the sum of their areas. And remember, area was the denominator, so we might expect something like 1 over R1 plus 1 over R2 is equal to the 1 over the equivalent resistance. But let's see if we can show that. I'm going to argue that the change in voltage from here to here is still V, because there's no voltage drop here or along here. Okay? That being the case, VI1 R1 must be equal to VI2, or rather I2 R2. Okay? These are all the same thing. Okay? But there's one more thing I'm going to argue here, which is that whatever current is coming into this junction must be split between these two, so that incoming current must be equal to the outgoing currents added together. Okay? That being the case, I could say V is equal to I1 R1, but I1 is really I minus I2 R1. And from this, we know that I2 is really V over R2. Okay? Or R1 I1 minus R1 R2 V. Okay, so now I'm going to go ahead and clear the screen real quick, and I'm going to start move the V over to the left side. So we've got V plus R1 over R2 V is equal to I R1. Okay? In other words, V times 1 plus R1 over R2 is equal to I R1. We're getting close. V is equal to I times R over 1 plus R1 over R2. Okay, going to divide top and bottom by R1. Get I 1 over R1. Okay, I lost the R1 here by dividing out. I'm going to lose, or again, a 1 over R1 here, and I'm going to lose that R1, R2. Okay? So we've got, again, an Ohm's law situation here, but in this case, the equivalent resistance is 1 over R1 plus 1 over R2, or 1 over R equivalent is 1 over R1 plus 1 over R2. Okay? Same thing as before. This is the equivalent resistance I've just found. I can find it, and it's then equivalent to just taking those two parallel resistors and putting one resistor in the middle with this value. Okay? Everything is the same. Really, very cool that that happens. All right. We'll work some more examples in class, of course, and I will see you in class. Bye.